when most people talk about decreasing costs of innovation, they focus on decreased networking costs. It's important. And now with social networking, it's possible to draw on input from people in a wide variety of forms, in email messages they write, blog postings, online chat rooms, web pages, and so forth. But when it comes to inventing and innovating, it's not just the decreased cost of networking that's facilitating that. For example, improvements in computer-aided design, CAD, improvements in simulators, really are playing a very significant role. When I mentioned the NASA antenna, John Cose's controller, the cross-action toothbrush, all of those were possible to achieve at low cost and quickly because a computer could generate models of designs and simulate them and evaluate them without having to build physical models. Now, in some cases, people have used evolutionary computation software to assist design of models that are built physically. But as you can imagine, it's very slow to do that. You could build a model of a toothbrush, test it physically, and then feed the results back into a computer to produce the next round. But when you do it that way, your costs go way up. The number of generations and the number of possibilities you can evaluate gets reduced dramatically. So increased availability of high-quality, fast simulators for simulating a wide variety of physical phenomenon is really driving this. And when I interviewed people for the book, many of them told me they are hungry for faster, better simulators, and many of them are actually, as part of their work, designing or tweaking their own simulators for their own particular field, whatever it may be, because that's what they need. Another kind of general phenomenon which is feeding this is the spread of what I would call design by programming or design by coding. In computer science, you create software by writing code, and then a computer generates the running software for you. Well, that same basic technique has been used for a couple of decades now to design microprocessors by writing code in the form of hardware description languages. My laptop here, which has a processor that has a few 100 million transistors, okay, those few 100 million transistors were not designed manually by any team, no matter how large, of human engineers at Intel. They wrote HDL code describing some of the high-level structure and function of the processor they wanted to create, and then they gave that code to a piece of software called a synthesizer, which generates the layout for the resulting processor. That kind of design by coding, many people believe, is and will be spreading to other fields, molecular computing, nanotechnology more generally, where it's both not feasible because of size and because of scale and complexity to engage in design manually.